So the implication part of natural deduction consists basically of two rules. And one of them is the implication introduction. And so I will give some examples where the only rule we are using for these derivations is the implication introduction. So let's consider the general form of the implication introduction. Suppose we want to show x implies y. X and y could be some complicated composite statements, but we want to argue that x implies y. So what the rule is saying is that if we, from an assumption x, from the assumption x can derive a y, then we are justified in concluding that x implies y. So this is the basic format. This line here is done by an implication introduction. While these dots simply means that I haven't specified how I actually come from x to y. Of course, in this case, we cannot justify y. If you're just given an x to y, there's no way I could justify that y. I will need some more information to do that. Now, let's give some real examples. So suppose let's look at an example like this. So the first thing we notice is that the principal connective for this formula is this implication here. So that suggests that the way we in some sense, in order to argue for this, if we work within constructive logic, we actually have only one choice here. We are forced to derive that line from an implication introduction. That means that we have somehow to show that from assumption A, that's what the box is doing, by the way. The box is telling us that we are working under an assumption. It's like a hypothetical world. In the real world is outside the box. What happens in here is something that is subject to this assumption A here. So we have the problem really has been reduced to that from assumption A we have to derive this formula. Now for the same kind of principle before, we are just using one rule, namely the implication introduction. So in order to argue this, we make another assumption. Now this assumption, so to speak, happening inside a world where we have this assumption. So we have to reduce the problem to this. And again, we draw another box on top. This is some automatic thing in some sense. When we have an implication between two things, we never really lose anything by putting a box on top and reducing the problem. So instead of proving this one, now we have to show that under assumption C we can derive this one. And we can continue here. This is the same as showing from D we can get to A. Now at this stage, this is a bit like building a bridge from a tunnel from two different sides. At this stage we are kind of finished. The question is just whether it actually is a validity proof or there's something we cannot justify. So let's look at it. Let's annotate the proof and see. Actually, maybe I should already here say that the critical line, we can see that it's a proof because all of these are just assumptions. But the thing is, can we justify that A we had here? All of these were implication introductions that automatically were justified, provided we could prove the box about them. But we are sort of left with the problem of showing we can deduce A from D. But the point is that A, we already are living inside a box where we have assumed A, so of course we can get that A from line 1. So the other parts here are just assumptions. So actually you can say always in the top of a box you have an assumption. And the role of the box is absolutely crucial to understand in these box proofs, because they are kind of keeping track on what we are assuming. So here we have introductions and introductions. Now let me do a bit more neatly write-up of this proof. And I will actually do it in Jape, so you can also see how you can do the same thing, but now in Jape. Now let's do the same proof in Jape. So I highlight the formula, and let's see, it's all about implication introductions. So let's see if I can find this. Okay, here it goes backwards. I mean, you have to click around in the menu a bit usually to find it. So I clicked on that, and automatically Jape actually works out that because I clicked on that formula, I did an implication introduction. What it means is that we introduced a box here, and really the task is now to get from A to this, and it's the same. This one, how do we justify that line? Well, in order to get from A to and then derive this one, we basically reduce the problem of showing that under the assumption B, we can get to this one. Let's do another one. So now we're almost done, you see. So in order to, we have reduced the problem to, so we basically, our aim is to get rid of these dots. The dots explains to us, that tells us that something is missing. We have to justify that line. So let's see, D implies A. The automatic thing to do when we have an implication like that is to say, well, how did we get that line? How did we justify it? Well, it must have been introduced by an implication introduction. So that's why I do this. And now Jape actually tells us that actually complete the proof. You can see every single line is justified now. The key thing actually is that this line 5 we can justify because we are already inside a box where we have assumed A, so we know A is true here. So I think often, I mean, Jape write a hypothesis here. Sometimes I think in class I have used line 1. It's the same, but I mean, this is full annotation proof. But all the boxes are crucial. Each box corresponds to an implication introduction. I will consider a few other examples.